Assalamualaikum and good day everyone. My name is Hakim and today I will be presenting my group report on the topic of limits from our Mathematic 2 course. The assignment was complete by me and my group members, which is Andy Ryan, Paul Gilbert, Muhammad Noraziz and Ahmad Arshad. I will go through three main parts of the report. The first one is concept review. The second one is problem solving, and the third one, which is the last, is a real world application. Okay, let's begin. My friend will continue first.
Hi, my name is Paul Gilbert. Now I want to present about our assignment is limits and for the subject Mathematic 2. Okay, definition of limit is a limit tell us the value of function is getting closer as the input get closer to a certain number. Even if the function isn't defined at that point, we can see the value is approached. Limits are important because they help us understand a continuity and a foundation for derivative and integral. Okay, now we go to the one-side limit. Okay, a one-side limit look the value of function approach as the input get close to a point from only one direction. The right hand limit consider value coming from the right, and the left hand limit consider value coming from the left. A limit exists only if both one side limits exist and are equal. One side limit is especially useful for piecewise function or point of discontinuity. Okay, now we go to infinity limit. What is infinity limit? An infinity limit happens when a function grows very large or very small when as the input get close to a certain value. For example, if the limit of fx as x approach as is infinity, it means fx increase without bound near a. If it is negative infinity, fx decrease without bound. Infinity limit describe vertical asymptotes where the graph shoot up or down near a specific x value. Okay, next we go to a limits law. Limits law are rules that help us find limits by breaking function into simpler parts. Okay, they apply to some different product quantities and power of function. For example, the limit of fx plus gx as x approach and equal the limits of fx plus the limit of gx as long as both limit exist. This law make calculating limit easier and justify common algebra step in calculus. We can see in the slide about limits law picture. Okay, now I want to go final my present. It is a squeeze theorem. Okay, the squeeze theorem is used when a function is trapped between two other functions whose limit we already know. If the lower and upper function have the same limit at that point, then the function is between also has that limit. This theorem is especially useful for trigonometric function or function that oscillate but stay within bounds. Okay, that for my present in part A.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Noraziz bin Zainal. So today I will I will present two examples of limit evaluation in calculus. I will explain each step clearly to show how we simplify. So for the first limit, we begin by simplify the numerator. So the expression x squared to minus 9 is a difference of square. So we factor it as x squared minus 9 can be factored as x minus 3 times x plus 3. After factoring, the expression become x minus 3 times x plus 3 all over x minus 3. After that, we cancel the common factor. So for the all value of x except 3, the factor x minus 3 cancels. So now we can substitute x equals 3 into the simplified expression x plus 3 equals 6. So the value of the limit for question 1 is 6. So for the second problem, we recognize that this is commonly known as a standard trigonometric limit. It often appears in calculus when studying derivative of a trigonometric functions. So from the geometry or using the square theorem, we know that evaluate the limit as x approach 0 of sines x divided by x. Using a non-trigonometric limit, we know that the limit of sines x over x as x approach 0 is equal to 1. So the value of this limit is 1. So thank you.
Hi. Okay, I will continue. For question number 3, the limit of quantity 5 x squared minus x plus 1 divided by quantity 2 x squared plus 7 as x approach infinity. To solve this, I look at the highest power of x, which is x squared in both the numerator and denominator. When I divide every term by x squared, the smaller fraction go to 0 as x become very large. You can see I have already provide the equation in the slide. So the limit become 5 over 2. Therefore the answer is 5 over 2. Okay, for the problem number 4, the limit is the limit of 1 divided by x plus 2 as x approach negative 2. At x equal negative 2, the denominator becomes 0. So the function is undefined. When x approach negative 2 from the left side, the denominator become a very small negative number. So the expression goes toward negative infinity. When x approach from the right side, the denominator become very small positive number. So the expression goes toward positive infinity. Because the left and right side goes into the opposite direction, the two sides does not exist. Therefore, the final answer is the limit does not exist. Okay, let's continue with question number 5, which is use the squeeze theorem to evaluate the limit of x squared times sine of 1 over x as x approach 0. Since sine of anything is always between negative 1 and positive 1, x squared times sine of 1 over x is always between negative x squared and positive x squared. both negative x squared and positive x squared approach 0 when x get too close to 0. So by the squeeze theorem, the expression also approach 0. So my final answer is 0.
Hello guys, my name is Ahmad Arshad bin Abdul Samad. Today I would like to share with you about definition of instantaneous speed. Instantaneous speed is the speed of an object at single exactly moment in time. We use the concept of limit to define it because an object speed is always changing. To find the exactly speed at one moment, we start by looking at the average speed over a small time interval. Then we make that interval smaller and smaller. As the time interval approach 0, the average speed approach a specific value. The value is the instantaneous speed. In other words, its rate of change of the object position at that exactly moment. On the position time graph, this is the slope of the tangent line. A real life example is a car speedometer. It examines this limit to show your real time speed while you are driving. So this example, we are learning how to find instantaneous speed using calculus. Step 1. Define the position function. We are giving the position of an object in meter as a function of time t in second. The function is s bracket t equal 4t square plus 3. So we want to find the instantaneous speed at t equal 2 seconds. Step 2. Use the limit of definition instantaneous velocity. Instantaneous velocity is defined as the limit of the average velocity by v bracket t equal lim delta t to 0 delta s divided delta t equal lim hash to 0 s bracket t plus hash minus s bracket t divided by hash.
Hello guys, my name is Andy Ryan Ana Aseng. So now I will explain for step 3. Apply the formula to the example. To find the velocity at t equals 2, we need to substitute 2 into the formula. This gives us v of 2 equals the limit as h approaches 0 of s of 2 plus h minus s of 2 all over h. And then we have to substitute the position function, which is of s of t equals to 4t squared plus 3. So the expression will become 4 times 2 plus h squared plus 3 minus 4 times 2 squared plus 3 all over h. And then we expand 2 plus h2 into 4 plus 4h plus h squared. And then we distribute the 4, 16 plus 16h plus 4h squared plus 3. And then we subtract 19, which comes from the second part. And then after simplifying, the numerator becomes 16h plus 4h squared. So now we have 16h plus 4h squared divided by h. And then we factor out h and cancel it. And then this leaves us with 16 plus 4h. And that is the simplified expression we will have to use for step 4. Okay, now I will explain step 4, evaluate the limit. Now we evaluate the limit to find the instantaneous speed at t equals 2 seconds. We start with the expression 16 plus 4h. As h gets closer to 0, so the term of 4h goes to 0. So the whole expression becomes 16 plus 0 equals to 16. That means the limit as h is 0, which is 16. So the instantaneous speed of the object at 2 seconds is 16 meters per second.